All right, so we're finding average rate of change. Average rate of change means 2-point slope of f of x equals x squared on the interval from 1 to 4. So if we're finding my y values, Jalen, what'd you do? Okay, that works. And you're for 4? 16. So she went to the graph, and that worked perfectly well. We also have an equation, so we could just plug into that and go 1 squared gets you 1, and 4 squared gets you 16. Both do the same thing. Okay, that's a good visual on what's happening. Once we've done that, we're finding average rate of change. So Luke, talk me through what you did. Wonderful. Yep, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. 16 minus 1 is 15. 4 minus 1 is 3. 15 divided by 3 is 5. That is the average rate of change. What we just found was the slope of the secant line. Okay, so if you went to this graph over here and 1 and 4 and made those two dots, okay, what we found was the slope between those two lines. Darn it, I tried. That blue line that I just made had a slope of 5. That is the average slopes in between those two lines. It doesn't really do us a ton. It gives us averages. And up until now in your math career, that's what we've wanted, the average slope. But now what we're going to do is we are going to find something a little bit different. What if you want to find the slope at a point, say x equals 1? We can't just do that. So before, we could find the slope between 2 points. Okay, but we want to find the slope at a single point. I want to find the slope of this red tangent line. All right, so if I drew this line through these 2 points, is that a good representation of my slope right now? Through P and Q. It's not very close to the red line, right? What if I move that Q a little bit closer, and I found the slope between that P and that Q? Is that closer to my red line? Yeah. It's a little bit closer. It's a little bit better of a slope, but the slope's still not perfect. What should I do with Q to make it a better line? Move it even closer, right? Like, so if I made it like right here, and I use those, oh, that's pretty close, but it's not perfect. I want Q to be how far away from P if I'm trying to find the slope and make it as close as possible. Almost on it. If it's on it, I can't find the slope, right? Because if it's the same point, the slope is going to be undefined. But I want that second point to be as close to it as we physically can. Okay? So look at this graph. That one. All right. So think about what we're trying to do. We're trying to find the slope at 1. Okay? We've got these two dots. So right now they're far away. The red line, the green line aren't very close. But if I make this red line, or the second dot, this second dot get closer and closer to my first dot. See how the red line and the green line are getting closer and closer to each other. The slopes are getting closer and closer. Okay? The difference between the two dots is getting smaller and smaller. Right now it's 0.35, 0.3. The lines are getting closer, 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 closer. I want to get them as close as I physically can. If I get them on top of each other, it's undefined. But if I make that distance in between as small as possible, I win. Those slopes are almost right on top of each other, and that's what I'm trying to do. I'm trying to make the difference between the two lines almost nothing. All right? That's the goal of today. What we are trying to find is the slope of a tangent line. Slope of a tangent line, or a better way of saying that, the slope at a single point. This is called the instantaneous rate of change. If someone were to ask you, what is calculus? It is finding the instantaneous rate of change. That is what calculus all is. Everything we do from here on out is finding the instantaneous rate of change. In calculus, we call that the derivative. We are finding the derivative. That is the slope of the tangent line. That is the instantaneous rate of change. All of those words, slope of tangent line, slope at a point, at a single point. That is what I'm doing all day today. That's what we're trying to do. Everybody okay with those phrasing? All that. Instantaneous rate of change, slope at a point, slope of a tangent line, derivative. All of those things mean the same. To do that, we are using this thing right here. This is called the limit definition of a derivative. The limit definition of a derivative. I'm going to teach it to you. You're not going to like it, but you're going to have to do it anyways. Know that eventually we don't have to do it this way anymore. We're going to do it this way for a couple days. There are problems that we need to use it in, but we're not going to use it in the same manner. Okay, so for the next 2 days, get over it. It's not super fun. I don't care. Okay, do the best you can. Try to figure it out, and then we'll work into it and make it a little bit better. All right, here's what we got. This looks like a big fancy formula. It is what you just said to me. It's what Cannon just said. He said, make the distance between the 2 dots as close as possible, right? The h in this problem is the distance between the 2 dots. This is just slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I wanted to be able to subtract my 2 x values and make it as small as possible. That's h. We're trying to make h approach 0. So the number on the bottom, we want to get closer and closer to 0. And on top, it's the y values. This is y sub 2. This is y sub 1. Where we've got f of x, that's this y value. And f of x plus h, that's the other y value. Where the h is just the difference between the 2 dots. It's kind of weird. Do the best you can. Which thing did I miss, Sean? The limit. I'll do it again. Here we go. So the h on bottom, that is the distance between the 2 dots. We said the best one would be if the 2 points were on top of each other, but if they're on top of each other, it's undefined. So we're trying to make the distance between the 2 dots as small as possible. Okay, so imagine we got this dot and this dot. I want that h to become smaller and smaller and smaller. I want the limit of h to approach 0. I want it to be almost nothing. Okay, that's the same thing in slope formulas, taking x sub 2 minus x sub 1. The 2 x values, I'm finding the distance between. On top, I'm doing y sub 2 minus y sub 1. Okay. The y values are what you get when you plug in your x values. So f of x plus h is this dot right there. That's going to be x plus h is the x value. I plug it into f to get my y. Same thing there. Okay. It'll make sense once we go. I know it's weird. You're not going to wrap your brain around it perfectly the first time. All right. Let's do it. So our job here is to find an equation for slope of the parabola y equals x squared. We did this on Friday in Desmos. Okay, you've already done this, but we'll see it again. So right now, to find the equation of slope, to find the derivative, we are using this equation right here. So I'm going to write that out. The limit as h approaches 0. It asked me to do f of x plus h. That means the formula you're using. This is the formula I'm using, x squared. The other way of saying y equals would be f of x. So that's f of x. I want to do f of x plus h. So what do I need to do with x squared to make it f of x plus h? Everywhere there's an x, I'm going to replace it with x plus h. And so it did say x squared. I'm now going to, instead of x, I'm going to write x plus h squared. Minus f of x. What can I write in here for f of x? Just x squared, because this is f of x. F of x represents the function we're messing with. We're messing with x squared, so that's my function. I get x squared. All over, on bottom, it just says write h. So we're going to write h right here. Questions to that point? I know it's weird. Ask me, so I can get you caught up before you get too lost. So again, f of x plus h, we took the function we had, which was x squared, and we, instead of x, we wrote in x plus h. And then we wrote minus f of x. This is f of x, so it's minus x squared all over h. This is a limit problem. So if I'm doing limit, is it Cam? Yeah. All right. If we're doing limits, we just plug in 0. What am I going to plug 0 in for? Limit as h approaches 0, so what am I going to plug 0 in for? H. Guess what happens when you do that? You get 0 over 0. So we can't just do that. We got to do something else. Think about the other thing we did. If we got 0 over 0, okay, now we got to factor. We've got to cancel. We got to plug back in. This case, it's not really factoring. It's more simplifying, canceling, and plugging back in. All right, so let's do that. So now we got to do another limit problem. Limit as h approaches 0. This is something I would memorize if I were you, because we're going to do it all the time. And if you just memorize it, it's going to make your life easier. Okay? Taking x plus h and squaring it. That means you are taking x plus h times x plus h. If you don't know how to do that, you got to FOIL it out. Okay? I'll do it once for you. So x times x is x squared. X times h is xh. Another xh. And then h times h is h squared. Or in other words, x squared plus 2xh plus h squared. We did that like the first day of school. Okay, you don't like it, but we did it. Memorize that. When you see x plus h squared, you're going to put that in instead. All right, so right here I'm going x squared plus 2xh plus h squared. Minus x squared. I didn't have to do anything with that. All over h. So we FOILed that thing out. We got 0 over 0, so I got to cancel something next. There's got to be something I can get rid of in order to not make this 0 over 0 anymore. What can I do from here? Is there anything I can simplify? X squared. I've got an x squared here. I've got a negative x squared there. Those two things are opposites of each other. They are going to cancel each other out. So they're gone. Anything else I can simplify? I can remove an h. So we canceled stuff out. There was an x squared and a minus x squared. That's always going to happen. Once you've canceled out all the opposites, x squared minus x squared, a 2x and a minus 2x, now everything left in this problem should have an h in it. Okay, so we've got 2xh, an h squared, and an h. Everything's got an h in it. So Cannon said, let's factor out an h. So on top, I get this. And on bottom, I just have an h. All I did is I took an h out of both things on top. Once I've done that, what can I do from there? Yeah, cancel an h on top and bottom. So now I'm just finding the limit as h approaches 0 of 2x plus h. Now it's not a fraction anymore, so I'm not going to have that same issue of getting 0 over 0. I'm finding a limit, so what do you think I do with that 0? Plug it in for what? H, because it's h. So I plug in 0 right there. I am left with my answer. That is called the derivative. This is a formula for slope. It's the derivative. We represent derivative with f prime of x. That little apostrophe, you read that as prime. Okay, so that is f prime of x equals 2x. Do you remember doing that on Friday? Remember how we had the little parabola and you had to draw the line? You got 2x. We just did it algebraically. On Friday, we did it with a graph. Today, we did it algebraically. Questions on what we did there? We're going to practice it. I know you're not going to be perfect. Anything that you got lost on that you want me to help you through? So we plugged into our formula. That's what we did first. We plugged into our formula. We FOILed. We canceled. We plugged back in. This gave us our formula, our derivative. That was part A. We found an equation for the slope. For part B, it asks you to find the slope of the parabola at -1, 0, and 2. -1, 0, and 2. So what they're asking us to do is to plug into this f prime of x formula. We said f prime of x is 2x. We are trying to find f prime at -1, f prime at 0, and f prime at 2. We're finding it at three spots. Once you have an equation, this is easy. Then I'm just plugging in. This was the equation we found, 2x. They are asking us to find the slope at these 3x values. So all I'm going to do is take those 3x values and plug them in. So if I plug -1 in, what am I going to get? -2. When I plug in 0, what am I going to get? 0. When I plug in 2, what am I going to get? 4. What we just did is we found the slope of the tangent line. Okay, let me give you a visual of that. Here's -1. Okay, the slope of the tangent line. As I move this thing closer and closer together, do you see that the slope is getting closer and closer to -2? That's what we found, right? It's not perfect because we're not doing it exactly right, but we're close. Okay, that's a tangent line. Notice that if I found the slope at 0, oh yeah, that slope is 0 at the bottom there. And then if I found the slope at 2, the slope at 2 of the tangent line would be 4. We got the numbers that we thought we were going to get. Okay, that was the key of what we were trying to do there. The last thing that it asks us to do is write the equation of a tangent line. This is something you're going to be asked to do a lot of. Write the equation of the tangent line. So let's do that. Anytime you see in my class, write the equation of the tangent line. We are going to use point slope formula. Okay, this is what point slope formula looks like. You need to have this memorized. That is point slope formula. There are 2 things you need for point slope formula. What 2 things do you need for point slope formula? A point and a slope. That is correct. Okay, I need a point. I need a slope. Okay, my x value is -1. So that's what my x value is going to be because I'm writing the equation at -1. How do you think I can find my y value if I know what my x value is? Plug it into what? I'm plugging into this original equation because that's going to tell me my y value because y was equal to x squared. So if I plug in -1, I get 1. Okay, then I need the slope. So the slope is f prime. That's the whole thing we found. F prime at -1. We found that right here. F prime at -1 was -2. Once you got those 2 things, now we're writing the equation of the tangent line. That's easy. Okay, this is point slope formula. We plug in for that. We plug in for this. Every time I write the equation of a tangent line, I always just do this. Y minus, parentheses, x minus. I just leave spots there and I fill in what I need. Okay, I need to plug in my x and my y. Oh, that's this right here. So y minus -1 becomes +1. Y minus my y value is 1. My slope goes in front of the parentheses. So my slope in this case is that derivative. It's that -2. Just leave it like that. You don't got to get y by itself. You don't have to distribute. Don't do anything else. That's my answer. Okay? Know what we just found. If I type that in right here, we got y minus 1 equals -2, parentheses, x plus 1. I get that blue line right there. And that blue line is the equation of the tangent line through the point -1, 1. It's touching that graph in one spot. That is what we're trying to do in this class every single day. Make sense on that one? At least what the picture looks like in the end. Again, I know this is not your favorite topic. When I was in calculus, this is the thing I hated the most. I am making it as simple as I can for you. Okay? I know it's not your favorite. Let's go to the next one. I know it's hot in here too. They picked a bad day to make the temperature hot because everybody is now mad and hot at the same time. It's a lot of fun to teach you. Let's go to the next one. Example 5. Find the slope of the parabola y equals x squared plus 5x. We are doing this at the point x equals 3. Okay? We're finding the slope of the parabola. When you see this right here, the slope of the parabola, oh, that means the derivative. Okay? We're finding the slope of an equation. That's the derivative. We got to use this thing right here right now. Eventually, we are going to do the derivative without this fancy formula. Jesse, how long will it take us to find the derivative of that, like starting on Friday? 3 seconds, I would say. Anybody in AP Physics? How long will it take you to find that derivative right now? 3 seconds? 3 seconds. Right now, it takes us 3 minutes. By Friday, I'll teach you the short way. You'll be a lot happier. Okay? But for now, it's going to take you some time. Find the slope of this parabola. The limit as h approaches 0. F of x plus h. Okay? F of x plus h. Well, this is f of x, right? This is y. That's f of x. Same thing. If I'm doing f of x plus h, what do I need to do with that equation? Plug in x plus h. Okay? Sorry. My thing keeps dying today. It's a good day. I'm plugging in x plus h for x. So in this equation, everywhere I have an x, I'm plugging in x plus h. So it's going to be, boom, squared plus 5. And I'm plugging in x plus h. X plus h. And this is the biggest thing you got to do. And then it says minus f of x. What am I going to write for f of x? X squared plus 5x. This is f of x, x squared. I don't know what I just wrote. X squared plus 5x. But if you wrote it like this, it would be completely wrong. What did I do wrong when I set that thing up? You've got to put it in parentheses, because if you don't put it in parentheses, you're only minusing the x squared. And you got to subtract the x squared and the 5x. And you write that all over h. Go from there. Simplify that thing with your neighbor. So we're taking this thing, we're trying to simplify. Okay? If we were to plug in the limit right now, we would get 0 over 0. So we need to simplify this thing. So x plus h squared, you have to FOIL that out. We just did it a second ago. It gets you x squared plus 2xh plus h squared. We're going to distribute the 5. So plus 5x plus 5h. Then I need to distribute the negative. So it's going to be minus x squared minus 5x all over h. That's my initial setup. Andrew, what can I simplify from here? I got an x squared. Here's a positive x squared. There's a negative x squared. Those two things are going to cancel. What else? 5x. There's a negative 5x. Those two things are going to cancel. Anything else that can just cancel like that? Opposites? If nothing else can cancel, that everything that's left should have the exact same thing. Okay, or I'm sorry, everything that's left should have an h in it. Does everything that's left have an h in it? Then we're doing it correctly. Okay, everything we have left has an h in it. This, and this. So my next step is going to be factoring out an h. So if I factor out an h on top, Macy, what's going to be left? Good. Yep. Wonderful. All over h. She factored an h out of everything on top. There's an h on top. Now there's an h on bottom. Now what? Cancel the h's. Those are gone. And so I'm left with limit as h approaches 0 is going to be 2x plus h plus 5. I'm finding a limit. So what should I do with that 0? Plug it in for what? H. So what are you left with? F prime of x. This is the derivative formula. That's what we just found. This is the slope formula. This will tell me the slope of the parabola is going to be equal to just 2x plus 5. That is the derivative formula. That is A. We found the slope of the parabola. Well, that's the equation. If I want to find the slope at 3, what do I need to do to find the slope at 3? Plug it in. So if I plug in 3, I get 11. That is the slope at 3. I found the equation. This is the equation. That could find it at any point. But then I just plugged in 3 to find it at that point. Part B asks me to write the equation of the tangent line. So that should be easy. Anytime I write the equation of a tangent line, I need a point. I need a slope. My x value is 3. How could I find the y value? The original. Good. We're plugging it into the original. So we're plugging in right there. So it's 3 squared plus 5 times 3. 9 plus 15. It's 24. Then I need to know the slope at 3. What's the slope at 3 going to get me? 11. So I'm going to put 11 right there. We're writing the equation of a tangent line. Y minus equals x minus. Y minus my y value, x minus my x value, and my slope goes right there. That is the answer I'm looking for. Okay, let me show you what that does. So all of that worked, but it gave me this right here. We had this equation, x squared plus 5x. It gives me that graph. If I write in that equation I just got, it was y minus 24 equals 11 x minus 3. And always goes to the wrong color. Let me change that color. Yeah, that's the equation of the tangent line. Okay, if I zoom out, you can see how it's sitting there, but it's touching that graph in just one spot. I'm going to change this a little bit. Let's go. Let's go -10. There you go. That's the equation of the tangent line. You can see that I'm touching in just one dot. That line is going through that single point like we wanted it to. Questions there? All right. Let's do one more. Okay. I know you're worn out, but we got to get through one more because my last class did too. All right. That form that we just did, that is called the limit definition of the derivative. That's the most common one. You're going to see h approaching 0 on that one. Okay. When we finished those problems, we always got an equation. Okay. Those equations are really nice when you want to find the slope at multiple points. Like on this one, we easily found the slope at -1 and at 0 and at 2. Just boom, 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 plugging in. Okay. But it took some time. We've got another limit definition of a derivative. It's this one right here. Okay. This one is faster, but it doesn't give you as much information in the end. Okay. So it's a little bit faster. This time we're not doing h approaching 0. We're doing x approaching c. Okay. When we talk about c, c is the place, is the x value we're finding the slope at. All right, so again, they're giving us a parabola. The c represents the place we're trying to find the slope at. All right, so if we look at this thing, it's just slope formula. There's nothing about this that's weird. This is y. This is y sub 2 minus y sub 1, x sub 2 minus x sub 1. That's all it is. It's just slope formula. Okay, so we're going to write an equation of the tangent line at c equals -1. So we're going to find the limit as x approaches what value for this problem? The c, and my c represents -1 because I'm writing the equation at -1. Okay? It says in my formula to write down f of x. What can I write down for f of x? X squared minus 3x plus 1. So I'm going to write that down. X squared minus 3x plus 1 minus f of c. F of c. How could I find f of c here? Good. F of c just means in this case f of -1. My c value is -1. It's just taking -1 and plugging into that original equation. So I'm taking -1 and plugging it in to this guy right there. So -1 squared would be 1 plus 3 plus 1. F of -1 is going to get me 5. So it's going to be minus f of c. So what am I putting for f of c? Minus 5. There's that. All over x minus c. So on bottom it's going to be x minus plus 1. X minus a -1, so it becomes x plus 1. Everybody good to there? We're finding the limit at -1. Guess what happens when you plug in -1? You get 0 over 0. Cool. So now what I need to do is I need to factor. Okay? So I'm going to rewrite this. My pen just died on me. Of course it did. So I need to factor that top part. So normally I don't want to rewrite this whole thing because that's just annoying. But I need to factor the numerator. Okay? So hopefully my pen works now. Good. I need to factor this. X squared minus 3x minus 4. What could I factor that into? X plus 4 and x minus 4 and x plus 1. That is this top part factored. So I'm finding the limit as x approaches -1. I factored the top part, and on bottom I've got an x plus 1. Now what can I do? Cancel the x plus 1s. Then what do you think I should do? Plug in -1. What am I going to get for an answer? -5. This is not an equation. This is a slope. By using this second formula, I'm finding the slope. I have found f prime at -1. It is no longer as handy. It is only telling me what the slope is at -1. It was faster. It was a lot easier to understand, but it doesn't tell me as much information. Okay? So you kind of got to pay attention. What am I trying to do? Am I just trying to find it at one point? Then use this method. If you're trying to find an equation, use the other method. Last thing we're doing is writing the equation of a tangent line. That should be easy because of this problem. Y minus x minus. My x value is -1, so it's y minus, or x minus -1, so it becomes x plus 1. What am I going to write with my y? Y minus what here? 5, because we found it right there. We needed that in my equation already, so I already have that. And in front of my parentheses, I'm going to write -5, because that's my slope. This is the equation of my tangent line. Okay, if I were to look at this graph, it would get me what I need. So here's my parabola. If we wrote the equation we just wrote, which was this thing, y minus 5 equals -5 times x plus 1. That is the equation of the tangent line. I'm touching it in one spot, and if I zoomed out, you could see what we were trying to do there. We wrote the equation of the tangent line.